Hi, everyone. I hope you had a great weekend. We are starting our new week with another topic, of course. This week, we're going over magnetic fields, magnets, and we're going to have some fun with that. Before I'll start talking about magnetism, which is chapter 11 in our textbook in Canvas. I wanted to remind you that we're working on project part 3. And if you were still working on your procedure design, that's absolutely okay. If you need a little bit more time, and then we essentially wanted to have a design so that you could then actually complete your experiment. If you have any questions, so this is when things get kind of more real, you did your research, you figured out, what you want to be testing, and now you're putting that into practice. So if you have any questions, please feel free to, email me, stop by office hours, and we can brainstorm together. If you need any materials, I can probably help you out. I know some of you are coming to campus so that we could figure out if you need something from the physics lab, or if you're remote, we can also, brainstorm through other solutions. So please don't hesitate to ask me if you have any questions about project part 3. That's the experimental part of the project. And I think that's the one that's probably a bit scary compared to the other ones, but in the end, I think that's the one that people have the most fun with. So hopefully that's the case for you as well. So we've learned about electricity. We looked at particles that were charged, either positively charged, negatively charged, and how they can interact together. And now we're going to be looking at something that's close, but to see how they relate, we need a lot of math, but we're not going to go there. So we're going to study magnetism, and you'll see how what we just learned in the previous chapter is going to sometime show up in this one as well. So probably the first thing you think about when you think about magnetism, magnetic forces, would be magnets. And we'll talk about how magnets work, and how peculiar they are, in the sense that you always see magnets with a north and a south pole, so you cannot isolate one from the other. And we're still looking for monopoles, so that would be isolating one or the other, and that's not something that we've been able to do. There's nothing in the theory that says that it should not exist. It just has not been seen ever. And we're going to see how the previous chapter relates with this one, so electricity and magnetism. As it turns out, as we're all sitting here, we are sitting in magnetic field. So it's due to the same thing that is keeping us at the surface of the earth. So the earth is pulling us due to gravity, but there are also some complex activity happening at the center that creates a magnetic field, which is actually very important. So we are also experiencing not only the gravitational field of the Earth, but also its magnetic field. And that's something that we use. So anytime you're using a compass, that's essentially what it's recognizing. We're going to see how those electric charges react in a magnetic force. What's really interesting is that to see any effect, you need that charge to be moving charge. That should remind you of currents. So we're going to see how that affects currents as well. And we'll talk also about induction, so which is a really fascinating topic to me anyway. The chapter is, structured similarly to all the other ones. You have a few intro videos, you have a pre-chapter check, and then you have the content. So we're looking at, what are magnetic fields, where they're coming from, what are, how do magnets work? And then we'll talk about magnetic force and induction. You have the handout as usual. This is a little experiment that I did for you using iron filings in a magnet, so you can really see those magnetic field lines. As always, you have a corresponding homework set and an activity discussion. We're using a simulation again for this one. So this is to look at a charge that is moving in a magnetic field. So let me take you to the simulation. So when you click on that, you'll get to this thing. And so you'll see that we have a charge that's going to essentially travel through a region of space here where you have a magnetic field. There is a number of settings that you can change, and I will also show you how, what these processes and whatnot mean. So I can do a quick demo really quick, but you can see as we're looking around, we're told that the charge is negative. B field is X. So what does that mean? That means that it goes into the page. All right. So the magnetic field, so that's what we call B field. The B field, magnetic field, is a vector. So it's a vector quantity. You can represent it with an arrow. And essentially, when you're looking at the X, it's like you're looking at the end of the arrow of the back of it. So it's going into the page. So it's showing you the direction of the magnetic field, so into the page. And we'll see what happens when you change it. When you have it going out of the page, then it's just a dot because you're seeing essentially the pointy part of the arrow coming at you. We have the magnitude of the charge that's going to be traveling in there. So right now it's 1e. So E you should be familiar with. At this time, you've seen the notation in homework and whatnot. That's the charge of an electron. So that's the magnitude of the charge of an electron. I say magnitude because this does not give us the actual sign of the charge. The sign is given on the first line. You can, so I clicked on here so we could see the grid. You can see that you can just click on each of these things to change it. So if I click on the negative, it becomes a plus. I can bring it back. If again, I want to change the direction of the field, there you go. So you can see it's a pointy part of the arrow. It's coming out. It's out of the page now. All right. So grid is on just because it helps us. But if you don't want that, that's totally fine. It gives you a scale. And you can also, change, by little increments or larger increments, the speed of the charge. You can change the strength of so let me increase. You can see that as I'm increasing the field strength, so that's B, I end up with more field lines, so that more arrows. So the more arrows means that my field is stronger, and I can also change the mass of my charge. All right, so essentially what you're going to do is, change the settings. Uh, I have these ones for now, and what I'm going to do is say fire. All right, so you see the charge is coming out of here. It went around a little, like a semicircle. And what you're going to do in this activity is pick a variable. So one of those variables, so you can change the sign of the charge, the direction into the page or out of the page of the magnetic field. You can change the speed of the charge, the strength of the magnetic field, and the mass. And so you can pick one of those variables, change it without changing the other settings, and then tell us what you observe. So how did that affect the motion of the charge? All right, so this is how you're going to respond to that. I don't know if you can hear the little birds in the background, but there's a nest right by my window. All right, and that's it for this chapter. So again, if you have any questions about the project, please reach out. Any questions about the course overall, or this chapter, please stop by office hours, and don't hesitate to reach out for questions. All right, thank you. Have a great week.